Hi everyone. Today you guys are going to discuss a role play on time chat translation. So I give intro of this case study. A company like Meta is building a real-time chat translation system. However, the system fails to maintain context across long conversation and produce inconvenient translations. So today students will discuss how deep sequence model can solve this problem. Start your session with a short, small intro of yours.
Hello, I'm Yogadharani from CC department. I'm Jayasuriya from CC.
I'm Janishya. I'm Anupriya. I'm Big. My role is problem analyst. So now I'm going to explain about the problem understanding. So the main issue in the system is the loss of context in the long conversations. The model translates each sentence independently without remembering previous messages. So this leads to inconsistent translations, wrong meaning, and poor user experience. So for example, we can say if I am the user now, so I went to the bank, next it was crowded. So system may not understand bank context, that is whether it is financial or river.
What is the core problem here?
The core problem is the system's inability to maintain context across long conversation, which leads to the inconsistent and inaccurate translations. So this might happen, treats each sentence independently, which fails to remember previous information, and it loses meaning over the long sequences.
My role is on basic model. Now I'm going to explain about basic RNN limitation. During training, RNN uses a back propagation through time. In this process, a gradient are passed backward through many times. As the sequence becomes longer and these gradients become very smaller. As a result, the model fails to update the weights properly and early information become insufficient.
Why RNN is not suitable for a longer conversation?
Because it is not suitable for long conversation. It cannot retain long-term dependencies due to the vanishing of gradient process as the sequence become longer. So the early information is forgotten, and this leads to a loss of context and inaccurate outputs. Example, in a long chat, RNN may forget the topic discussed early and produce inconsistent translations.
I'm going to play a role on advanced model. To overcome the limitation of RNN, to handle the sequence, we use the advanced models like LSTM for a long short-term memory and GRU for a gate recurrent unit. These models are specifically designed to capture long-term dependency and memories content over time. So they improve the content retention and translation memory consistency. And the example is in the long term, LSTM remembers earlier topic, better translation.
How does LSTM improve performance?
LSTM improves performance by effectively handling long-term dependency using its gating mechanism, and it stores the importance of long-time informations and remove the irrelevant data for gates, prevents the vanishing gradient problems, and it helps the better content retention and more accurate prediction. So I am going to play a role on bidirectional RNN. Even LSTM has limitation. To further improve, we use bidirectional RNN to understand the both past and future content. We use the attention mechanism. It focuses on the improvement of words in the sentences. It gives more weight to relevant parts. Bidirectional RNN provides the complete content, while attention ensures focus on important information, together improving sequence understanding significantly. For example, the bank near the river. Attention helps for the focus on the river, correct meaning.
What is the role of attention here?
It helps the model to focus on the important parts of the input.
So I'm going to explain about the final architecture. In this architecture, it involves about sequence encoder decoder with bidirectional LSTM and attention mechanism. So it mainly consists of three main components, which is encoder, attention mechanism, and decoder. At first encoder deals with bidirectional LSTM. The use of encoder is at first we need to give an input. For example, I went to the bank near the river. So encoder at first fully reads the line. Then it deducts the word river, so that it understands that it means about the river side, not about the bank and money. So it clearly understands about the full sentence and passes message to the attention mechanism. Second one is attention mechanism. Attention mechanism's work is to deduct the most important words which needs to gets translated to give the meaningful sentence. In our case, the word river is the most important word. So it collects word which is the most important to get translated. So in our case, river is collected and then it gets passed to the decoder mechanism. It is the final component. The decoder mechanism takes the word river and it fully analyzes the sentence and gives the meaningful translation. So the final architecture gives us the long conversation and accurate sentences, which gives the most accurately translated sentence.
Students have discussed the concept very well with a clear explanation and a good teamwork. Their ability to connect the theory with the real world application shows effective learning. This is how modern system like real-time translation work. Thank you all. Thank you everyone.
Thank you.